Hello everyone, welcome to the next session on ANSYS CFD tutorials. In this session, we will analyze the 7-digit NACA aerofoil 747A315 for its fluid flow analysis. We will analyze this aerofoil at a speed of 25 meters per second flowing through air and at an angle of 18 degree. This angle will be more than the critical angle of attack, which is 15 degree. So we will see what will be the result of such an angle of attack on this aerofoil, which is moving at a speed of 25 meters per second. We will start by double clicking on Fluid Flow Fluent. We will first import the geometry. Then I'll double click on the geometry itself. Now this airfoil is of 3D type. So what I'll do is I'll go to XY plane, look at. I'll go to sketching and choose rectangle. And I'll draw a rectangle over the airfoil. I'll give it dimensions. H1 is 200. L3 is 50. This is 50 and V2 is 100. Next we'll go to extrude and we'll select the sketch 1. Apply. Operation is add frozen. Depth is 500 because that's the span of the aerofoil as well. And I'll click on generate. Now you can see the line body suppressed. Surface body also I'll suppress. There are two bodies left here. One is the airfoil and one is the bounding box. Next I'll go to create body transformation, rotate. I'll select this airfoil body. Axis selection is the XY plane. This is the axis about which the airfoil will rotate. You can see here it has rotated. I'll change the angle to 18 degree and I'll generate. Next I'll go to create boolean. I'll select here subtract. Target body is the outer one and tool body is the airfoil and generate. So now you can see here the geometry is ready. We will close this. I'll go to mesh and double click now. I'll go to mesh. I'll change the sizing to 0.01 meter and generate. You can refine this mesh further. I will leave it to as it is. Now I'll rename the sides. So this is the first one. This is the symmetry one. This is the top surface. This is the outlet. This is the airfoil. This is the inlet. This is the bottom surface. This is the symmetry 2. You can see all the name selections over here, all 7 of them. Just go to mesh and update once again. You'll get a message here, the mesh translation to Fluent was successful. After this, the meshing completes. So we'll close this now. We'll go to setup and double click. I'll select double precision, solver processes 2 and start. You can see here the solver type is pressure based. Velocity formulation is absolute. Time is steady. In the previous analysis, which was of 2D type, the analysis type was also mentioned, whether it is 2D or 3D. Here it is not required because it is directly a 3D type of analysis that we are doing. We'll go to models. You can see here the viscous model is the SST K omega type, which is by default. You can change it if required. Material again is air for fluid by default. I will not change it. I'll go to boundary conditions and double click on inlet velocity. I'll give the velocity magnitude as 25 meters per second and apply and close. Then I'll go to reference values and double click. I'll compute from the inlet. Reference zone is a solid. Next I'll go to methods and double click. Here the turbulent kinetic energy model is a second order upwind type. Then I'll go to monitors and select report files and double click on it. Here I'll select new. I'll click on new once again. I'll go to force report drag. Drag coefficient is the first one, so I'll just rename this as drag space CD. I'll select the airfoil, print to console, OK. Again I'll click on new force report drag. This time I'll select drag force. I'll rename this as drag space force. I'll select the airfoil, select print to console, OK. I'll click new force report lift. I'll select lift coefficient. Here I'll rename this as lift space CL. I'll click on print to console. I'll select the airfoil. OK. Then I'll click on new force report lift force. I'll change this to lift space force. I'll select the airfoil, print to console. OK. All four are done, so I'll click on OK now and close this. Then I'll go to initialization and double click. Hybrid initialization is what I'm going to choose. I'll click on initialize. It is done. I'll go to calculation activities, auto save every iteration. I'll get the value as 25. OK. Then I'll go to run calculations and double click. Number of iterations I'll give as 250 and calculate. The calculation is complete. You can see here this is the drag plot. The highest value is 0.0226. Here the drag force is 8.6559 Newton. The maximum value of lift is 0.1354 and the value of lift force is 51.8494 Newton. Also, we will check here where the solution has got converged. It was the 58th iteration. We have given 250 iterations to run for, but after the 58th iteration where the solution got converged, the solution has stopped. So now we'll close this. OK. We'll go to results and double click. We'll first click on streamline. OK. Start from symmetry 1. Number of points are say 90 and apply. So you can see here this is the flow over the airfoil. I'll go to animation. I'll select sweep animation. I'll select the streamline one. I'll remove the forever loop and create 3 repetitions. I'll make this a bit slow and run. Now that's the size of the ball, which is quite large. We go to options, change the symbol size to 0.4. OK. And you can play once again. So you can see here the size of the ball has reduced. You can observe that in this zone where the velocity is less, there is a slow motion of the fluid. This is the zone where you will find that vortex creation may happen. The separation will take place over here. You can see here there is already separation at this speed and at this point in the aerofoil. So that's how you analyze this. The maximum velocity is 68.39 meters per second, where the color is red over here. I'll close this now. I'll go to contour. Okay. We'll just remove the streamline one. Location is the symmetry one. Variable is pressure. Range is local. Number of points is 110. We'll go to render and remove show contour lines and click on apply. So you can see here, this is the zone where the pressure is higher. Highest value is 726.681 Pascal, which is here. In this zone, it is lower and it is minimum at this tip end. The lowest value is minus 3389.76 Pascal. We'll remove this and we'll click the contour button again. Okay. We want to create the contour for velocity now. Range is local. Number of points 110. Render and remove the show contour lines and click on apply. Now you can see here in this zone where the color is blue, the velocity is 0, which means the separation will take place and the vortex formation will be there. Here the value is highest, which is 68.2584 meters per second. Here the value of pressure was least and it was maximum here. So the velocity is less here, and here also you can see the velocity has a range. So that's how you analyze this 7-digit NACA aerofoil at 18-degree angle of attack. You can increase the angle of attack and check what will happen. But if you go too higher and you take say 20 and above, there will be stalling of the aerofoil. So with this, I end the session. I hope you understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.